Any concept or theory in science comes with pros and cons. In the last video lecture, we discussed advantages of using sorption isotherm. Now let's see what is the criticism to the theory of water activity. Firstly, in case of frozen food system, water activity cannot accurately measure product stability because at sub-freezing temperatures, relative vapor pressure is not function of composition of food but is a function of temperature. Meaning, given the relationship between relative vapor pressure and water activity is also dependent on temperature rather than on the composition of the product. As a result, certain composition related reactions like diffusion control reactions and redox reactions cannot be explained accurately or predicted well using the concept of water activity. Second, we have something called as hysteresis. So what is this hysteresis? The sorption characteristics of water depend on the history of food. What is meant by history of food? In order to study sorption characteristic, we usually subject the product to a drying process, okay, wherein you have complete removal of water, and then subject it to a remoistening process. So the curves obtained for desorption and resorption should actually, under ideal circumstances, superimpose. But in reality, this is not the case. In reality, we see that there is a difference between desorption and resorption isotherms. Meaning the curves do not superimpose exactly. And this discrepancy that we see could be either because capillaries are not rehydrated efficiently, as moisture is not able to readily get uh, into the capillaries during the moistening process. It is quite possible that water behaves like free water, or when a biomolecule is present, it can cause changes to the sorption characteristics due to unfolding during drying. You're subjecting it to such high temperature that there will be unfolding of these biomolecules, and they try to interact more readily with water. The effect of hysteresis depends on temperature and composition of the product. It is generally lower at higher temperature. Beyond 80 degrees Celsius, it's considered very low. It has no impact at all. The magnitude of hysteresis, the shape of curves obtained, the inception and termination points of hysteresis loop can vary widely depending on factors such as the type of food we are dealing with, the physical changes it undergoes when water is removed or added, temperature, the rate of desorption, resorption, degree of water that is being removed from the product. Then third one is that water activity is a parameter which can be well used in equilibrium conditions. So because it's a thermodynamic parameter. So it always talks about thermodynamic stability of the system. So when we talk about the use of water activity in predicting the stability, an assumption that is made blindly is that food is in a state of thermodynamically equilibrium conditions. However, food in reality is only kinetically stable. For instance, to explain that, I would like to give you an example of that growth of ice crystal. Why is food considered kinetically stable system? You have ice, and ice crystals in frozen foods, they can grow via something called as osmolar ripening. And that's the reason we say that it is kinetically stable, or it is in a state of dynamic equilibrium. Got it? Not thermodynamic equilibrium. Pseudo-amorphous compounds can be converted to crystalline if sufficient amount of water is present. Now, what we have to remember is that always have this in the back of your mind. Whatever theory we are using, it's always better to use a combination of theories to explain the behavior of water and also predict the stability of water. Why? Because water in food, it reacts in various manners with various biomolecules, and these reactions are definitely complex. It cannot be easily explained by any one theory or concept. It is generally explained well by a combination of theories and concepts. Thank you for staying with me through the video. In case you have any queries, please feel free to put them in the comment section and I'll get back at the earliest. In case you like my video lectures, please subscribe and share it with your friends. Thank you.